Assalamu alaikum students, welcome to this new video. And remember, in the last video we did chapter number 5 and we tried to understand the subgame perfect Nash equilibrium and how to solve such games. So in today's video I'm going to explain you how to do the alternative representations of the normal form and extensive form games. So I will start by giving you an example of solving a dynamic game. I already showed you in the previous video, but here I'm just want to revise the topic. And remember, when we are solving a dynamic game, we have to solve it by using a backward induction method. And remember, the solution method in the dynamic game is subgame perfect Nash equilibrium. We call it subgame perfect Nash equilibrium. And how do we solve a dynamic game by using backward induction? The idea is that we solve the game backward. Okay, so let me explain you what do we mean by backward. So the original timing of the game is that player 1 is moving first and he can choose up and down, and then the second chance is for player number 2, and he can choose between left and right if player 1 chooses U, and then he can choose left and right when player 1 is choosing D. So this is the original timing of the game. But now when we solve it backward, we start from player number 2. So we first find out what is the best strategy or best action for player number 2. And we have to solve it on all the possible situations. So we have to solve the game for player number 2 here, and we also have to solve the game for player 2 here. So let us start the game here. We solve the problem for player number 2. So here for player number 2, there is an option to play L and get a payoff is equal to 1. And then he can also play R and he can get a payoff equal to 0. So now we have to decide what is best for player number 2, whether L or R. By playing L, he is getting 1, and by playing R, he is getting 0. So of course, L is better. So here, the best choice for player number 2 is to choose L. And then we go to the other side for player number 2. And again, there is a choice for player number 2 to play L and get a payoff equal to 1, and he can play R and get a payoff equal to 2. So again, we have to just compare the numbers for player number 2, and we can see that by playing R he can get 2, which is higher than 1 which by playing L. So again, the best for player number 2 here is to choose R. So now we go back to player number 1, and for player number 1, again the possibility is that he can choose U. Okay, if he chooses U, and we know that player number 2 will choose R, so he will end up getting 2 here. On the other hand, if he chooses D, and we know that player 2 will choose R, so he will get a payoff is equal to 3. So for player number 1, now it is very easy to decide. By playing U, he can get 2, and by playing D, he can get 3. So which one is bigger? Of course, by playing D, he can get a higher payoff of 3. So this is the solution of the game. Player 1 will choose D, and player 2 will choose R, and the game will end. The payoff for player number 1 will be equal to 3, and payoff for player number 2 will be equal to 2. So let us now write the subgame perfect Nash equilibrium. So the subgame perfect Nash equilibrium for the game is that player 1 chooses D, and player 2 chooses, or his strategy is LR, and then the game ends. You might be wondering that player 1 is only choosing R here, and he is getting, and the game ends. So why do we write L here? This is because we have to write the strategy for player number 2. Okay, so we have to write the complete plan of action. So we write that if the game reaches here, player 1 will choose L, and if the game reaches here, the player 2 will choose R. So that is why we write L and R. But of course, the original or the actual equilibrium path is that player 1 is choosing D and player 2 is choosing R, and the game ends. Okay, so this is equilibrium path. I hope you understand. So here is another example for you to work on. Please find the subgame perfect Nash equilibrium of this game. So our next topic is the alternative representation of the games. So we basically divide, games or, game theory into two types of game. One is the static games where player moves simultaneously, and then we have dynamic games where player moves one after the other. So if you have a static game, then the best representation of the static game is to write the game in a form of a matrix, and this is called matrix form of the game. And then if it is a dynamic game, then the best way to write the game is to write it in a tree chart, or we call it extensive form of the game. But now we would like to learn how to write a static game into an extensive form or tree form. Okay, so we want to write a static game into a tree chart. And similarly, we would like to write a dynamic game into a matrix form. Okay, so this is what we want to learn now. So now I am going to explain you how to transform an extensive form game into a matrix form or normal form game. So this is the game what we have, and we want to write it in a matrix form. So the first step is that we have to write the action and strategies of each player. So let us start with player number 1, and for player number 1 we can see that he can choose either U or he can choose either D. So if I write the actions for player number 1, then he has two actions like U and D. And then what are the strategies? Because player 1 is only playing one time, so there is no difference between the action and strategy. So the strategy for player number 1 is also U and D. Okay, so now we move to the player number 2. And for player number 2, you can see that player number 2 can choose two action, left or right. Okay, left or right. So if I write the actions for player number 2, it will be left or right. But remember that player number 2 has the possibility to play left or right here, and he also has the possibility to play left and right on this side of the game. Okay, so his action is left and right, no problem, but his strategies will be a complete plan of action. Remember, strategy means a complete plan of action. Like, we have to say that what he will do if he is going to play here, and in combination what he has to do here when the game reaches here. So let us take the first possibility. The first possibility is that he chooses L on this side of the game. Okay, he chooses L here. Okay, and what does it mean on this side of the game? When player 1 is choosing U, he is choosing L. And then on the other side, if player 2 chooses D and he chooses L. So this is complete plan of action. This is a possibility number 1 for player number 2. He chooses L if the game is here, and he chooses L again if the game is here. So this is the first possibility, L and L. Okay, I hope it is clear. And then what is the second possibility? The second possibility is that he chooses L on this side of the game, okay, and then he chooses R on this side of the game. Okay, in other words, he chooses L when player 1 is choosing U, and he is choosing R when player 1 is choosing D. So the second possibility for player number 2 is that he chooses L and R, meaning L on this side and R on this side. So this is second possibility. And then the next possibility is he chooses L here and he chooses R here and he chooses L here. So this is third possibility. And the last possibility is that he chooses R and R. So these are the four possibilities for the complete plan of action or strategies for player number 2. And now we have to write the payoff matrix. Okay, and let us write the matrix here. And as you can see, for player number 1, there are only two possibilities for the strategy, U and D. And for player number 2, we have the four possibilities, LL, LR, RL, and RR. They are these four possibilities. I write them here. And now let us write the payoff in here. So let us take the first one where player 1 is choosing U, and the strategy of the player 2 is to choose L here and L on this side. Okay, so according to this possibility, you see player 1 is choosing U and player 2 is choosing L, so the game is coming here. Okay, so this is the payoff. Player 1 will get 2 and player 2 will get 1. So we can write this number here. And then the next possibility is that player 1 is choosing U and player 2 is choosing LR. Okay, so let us draw this first. Player 1 is choosing U and player 2 is choosing LR. So LR. So now again the game is coming here because we have to follow the path. So the game is coming here, and again the payoff is 2 and 1. The next possibility is player 1 is choosing still U and player 2 is choosing R and L. So again, if you follow the path, you get a payoff equal to 0, 0. So this payoff comes here. And the next one, player 1 chooses U, player 2 chooses R and R. So again, if you follow the path, you will see the payoff is equal to 0. And now we go to the other possibility for player number 1, that he is choosing D, and again we start with player 2, L, L. So we are here. Okay. So what is the equilibrium path, or what is the payoff path? So the payoff path is here. So we can write this payoff here, where player 1 is getting -1 and player 2 is getting 1. The next one, D, and then player 2 is choosing now L, R. And again, if you follow the path, you see the payoff is equal to 3, 2. The next one is D, and then R, L, R, L. And the payoff is -1 and 1. And the last one is R, R. So again, if you follow the path, you will see the payoff is 3, 2. Okay. So this is how we transform an extensive form game into matrix form. Okay. I hope you understand. So now I'm going to show you how to transform normal form game into an extensive form game. So this is a normal form game or simultaneous move game of Prisoner's Dilemma. If you remember, we have two players, player 1 and player 2, and player 1 and player 2 have the option to choose quiet and confess. And remember that this is simultaneous move game, which means that player 1 and player 2 have to choose their action at the same time. Anyhow, there is no timing involved, but let us try to write this game in extensive form, or in the form of a tree. So if you see, for player 1 we have two options, quiet or confess, and then We also have the options for player number 2 to be quiet or confess. And now we have to write the payoffs. So let us look at the first one where player 1 is choosing quiet and player 2 is also choosing quiet, and the payoff is equal to 3, 3. So we are here quiet and player 2 is also choosing quiet, and we need to write the payoff here 3, 3. And then the next possibility is that player 1 is choosing quiet and player 2 is choosing confess. So player 1 is choosing quiet and player 2 is choosing confess. So we end up here. The payoff will be 1, 4. And then the next possibility is that player 1 is choosing confess and player 2 is choosing quiet. Player 1 choosing confess and player 2 is choosing quiet. So we will get the payoff here 4, 1. And then the last possibility is that player 1 is choosing confess and player 2 is choosing also confess. So confess and confess. So we get the last payoff which is written here. But remember that I told you that this is a simultaneous move game, which means that when player 2 is going to choose between quiet and confess, he do not know if player 1 has choose quiet or confess. So the question is that how do we make it visible here in this game, like player 2 do not know what player 1 has selected. So for that we just make another circle. We say that this is an information set. In this information set, player 2 does not know if he is here or if he is going to take the decision here. Okay, so this is called an information set. Player 2 is deciding about quiet and confess, but he do not know if he is deciding about quiet and confess here or if he is deciding quiet and confess here. So we make this big circle to show that they are player 2 do not know the action taken by player 1. So now this is the called dynamic form of the normal form game, or this is the extensive form of the normal form game. So there is some homeworks for you. So in this game you have to transform it into a normal form game the way I explained you. And in this game you have to transform the normal form game into extensive form game. And thank you very much for listening. See you in the next video.